are doing well. This is the sixth session of tutorial for Fluid Mechanics 1, Chapter 2, Section 2.11 is about buoyancy, flotation, and stability. The question is, a 1 diameter cylinder mass is with mass of m is connected to a 2 meter wide rectangular gate. The wide is 2 meters. Gate as shown in this figure. The gate is to open when the water level H drops below 2.5 meter. H 2.5 meter opening gate. Determine the required value for n. Neglect friction, the gate hinge, and the pulley. So, in order to do this, we have to make the free body diagram of the forces exerted on the cylinder as well as the points. So, I have provided my text on the screen. So, let me just erase the whole picture and just draw the free body diagrams. So, the free body diagrams are like this. This is the tall side of the wall. These are the hinge forces, Hx, Hy. There's a resultant force. There's a cable tension. And this distance is h divided by 3. Why is this amount? Owing to the fact that there's a water and the pressure distribution is like this. It is triangle. For the triangle, when we want to pinpoint the location of exerting Fr, it's going to be exerted on H3 from the bottom. So it is due to this figure. And for the cylinder, we have this Ng, cable tension to the up, and the flotation and the buoyancy force. So let's calculate the Fr. Fr is equal to gamma HCA, which is equal to gamma H divided by 2, since as I told you in the text from the session about hydrostatic force on the plane, it is H2, H divided by 2, and area is H multiplied by 2, since the 2 is the weight. So, as a result, we're going to have Fr as gamma H to power 2. So, let me just write the Fr down here. Fr is equal to gamma H2. So, in order to have all of the devices and in order to have the cylinder in the equilibrium, because, since all of the systems should be calculated in an equilibrium status, we have to take a momentum about point O. It means that sigma of MO should be equal to 0 for equilibrium. So this is point O. This is 4 feet. This means that 4 multiplied by t is equal to H3 multiplied by FR, which means that T is equal to when we should substitute gamma H to power 2 here, we're going to have T as gamma H to power 3 divided by 12. So, T is equal to gamma H to power 3 divided by 12. So, in order to have this side in equilibrium, means that T minus mg minus f is equal to mg minus fb, which means that via gamma via mass. T is to the up, mg is to down, and also fb is to the up. Since, as I told you in the instructional session, the buoyancy force is the force from the fluid to the opposite direction of the device is exerted on the fluid, in the fluid. So this means that m is equal to T plus gamma v of mass divided by g. So all of the question is totally answered. We just need to substitute. T plus gamma v of mass divided by g. T is gamma H3, H to the power 3 divided by 12. Gamma is the gamma of water. And the V is gamma P over 4 multiplied by 1 to the power 2 multiplied by H minus 1. Since we have the H is total here and the 1 is here. So, if we substitute 2.5 here, since it is said that drops below 2.5 meter, we're going to have G as 9.8 meter per square second. Gamma is 9.8 multiplied by 10 to the power 3 Newton per cubic meter. And the gamma, and there is nothing left. Doing all of the calculations, we're going to have M as 2,480 kilograms. So this means that we have to have the mass of cylinder as 2,480 kilograms to drop the level below 2.5 meters. So the point of this question is here. This distance, which is involved in the mass, the volume of the mass. We calculated the tension of cable from the free body diagram at the left side, and then exerted in this formula to verify the mass of the cylinder. So guys, this is the end of this session of tutorial. I'm really glad that you have accompanied me till this moment of video. Please subscribe the channel in order to get the notification of following tutorial sessions, and please solve the questions by yourself, this question by yourself, in order to be master of this kind of questions. Please don't hesitate to make any comments or questions either in the comments or email address I'm going to provide you at the end of this video. Take care of yourselves. Have a nice day. I bid you all farewell.